Okay, welcome back. All right, so I wired up, I have in the wiring diagram, three LEDs, a red, green, and a blue. And I included three different samples of code snippets in here to show you some of the different functions, counting, and also just some functions entering in values and how it works. And I actually wired both projects simultaneously with the independent LEDs and the color changing LED over here, but it's really hard to see the colors just because of the way the cameras work and getting the optics and everything correct. You can see a lot more color using your naked eyes, but it's kind of hard to see the colors using your video camera. So what I want to do is talk about the code on these particular projects. So I'm going to pull up the first one, if I can get it here, and that is this one here. And I used a LED on pin number 19, and we declared that variable to start with. I didn't put wiring instructions in here. Basically, it's the LED. Positive side goes to pin 19, negative side goes to ground, as you can see in the wiring diagram below. And then I use that variable LED blue as an output, declared it as an output in the setup, and then we have a loop. And what this loop function is doing is simply this. It's counting through the variables from 0 to 255. All the pins on a ESP32 are PWM pins. If you had Arduino, you had certain pins you could use and certain ones that would not work. All of them will work as a PWM pin on all of the I/O pins. Some pins are reserved with special functions, and you might find those out if you experiment a little bit or run into odd behavior. But you can experiment setting different pins. And what we did here is we set up a counter. We started at 0, and if A is less than or equal to 255, we add 1 each time. And then we write to pin number 19 that value between 0 and 255. That basically tells the brightness or the intensity. Short delay, and then it will run this loop again, adding until A gets up to 255, which would be full brightness. And then it goes to the loop here where it subtracts 1 each time. That's what that negative minus minus is it'll start A equals 255. When A is greater than or equal to 0, subtract 1, subtract 1, subtract 1 each time, and it'll write to pin 19 that value going down, and short delay between them, and just run that loop over and over and over. That will give you the what they call the breathing LED, going from light to dark, and that is the first section of code that they have on here. So let me go into the next one. Okay, on this piece of code we did something a little bit different. We actually assigned, and the only way you're going to see this clearly is if you hook it up to the RGB LED. That's the LED over on the right hand side of the board that has all of them mixed together. I still have it on the independent LEDs down on the bottom. I have the independent ones down here, and I have the RGB LED up here. So that's the only way you're going to see these two colors that come through. So if you're looking at this code, what it does, it declares my pins, and I put red on pin 19, green on pin 18, and blue on pin 16, and I declared them all as an output. And then we created a function here, and I'll show you what that is. It's actually in the loop. It calls this function, but down here you'll actually see the function. It says void RGB color, and we're going to take in 3 values from it: integer red light value, integer green light value, and integer blue light value. And then we're going to write those. Analog write the red light pin to the red light value, green light pin to the green light value, and the blue light pin to the blue light value. And those are going to be the values that come from up here. So what this is doing is the loop calls this function here, which is what we just named below, and it says the red is going to be on, green is off, blue is off. It's going to wait for a second. It's going to call the same function, and since this is 0, it's going to turn the red off, green on, blue off. It's going to delay for a second. It's going to do the same thing, except now red is off, green is off, and blue is on. Then it's going to start to do mixtures of these colors. So it's going to turn red on, green on, and blue part way, and they call that raspberry. Or they call this mixture cyan or magenta. And it will just run through and do different color combinations with 1 second delays between them. And all of that is from defining these functions here and then just calling each one in this little function routine. And the last code snippet that we included here uses the same pins, 19, 18, 16 for red, green, and blue, respectively. And we put a delay value in here, so we can just change that in one place if we wanted to speed it up or make it go faster. We set our pins as outputs, and what we're doing here is we're fading through and color changing each LED. So it's going to go through and count all the way up from 0 to 255. And it's going to do different things with the colors. It's going to do the red one at whatever my I value is. It's going to do the green as opposite, 255 minus I. And it's going to do no blue. And my delay value is in there. And then it's going to do another pattern where it counts from 0 to 255. It's going to do the red at 255 minus I, green at 0, blue at the I value, and pass these parameters through and just go through a looping pattern. It's kind of neat to see this in the separate LEDs, but then also in the single LED pattern. So experiment with the wiring and hook up the LED to the one with all the colors in it, the RGB LED, which has them all mixed together so your eye kind of blends the colors. So with that, do a little bit of experimenting, change the time values, change the numbers. Feel free to experiment and see what you can come up with and learn about the functions and also the loops for counting as we go along.